Hello, and welcome to the area under a curve and sigma notation tutorial. First, we are going to start with the sigma notation, which is also called summation notation. The equation that we are going to use for this lesson is y equals 1 half times 2 to the x, and our boundaries are 1 is less than or equal to x, which is less than or equal to 6. Back to sigma notation. It's very important that you know what each part of the equation represents. To the right of the e, or sigma symbol, is the argument and is also what you are solving. Above and below the e is what are called indices. The bottom indice letter is also called the index, which for our purposes will be represented with a k. Above the e represents the largest number you are substituting for the variable in order to solve the argument. Below the e is the index, and it represents the value of the variable in the argument. It is also the smallest number you will substitute into the argument. With our equation, we will substitute our equation 1 half times 2 to the x in for the f. X sub k is going to represent the change of x plus a. For our equation, the change of x is 0.625, and the a, our initial starting x value, is 1. And then for the rest of the equation is going to be multiplied by the change of x, which we'd plug in again, 0.625. Also, above the e, or sigma symbol, we plug in a 7, and below it we will set k equal to 0 for the left endpoint rectangle's sigma notation. For our right endpoint rectangle's sigma notation, we will plug in an 8 above the e, and below it set k equal to 1. Important rule, your right endpoint rectangle will always start at 1. In order to find left endpoint rectangles and graph them, the first thing you need to do is look at the equation and inequality. You are going to take the difference of your largest boundary, 6, and your smallest boundary, 1, and that gives you 5. The next thing you do is divide that answer from the amount of rectangles you are planning on creating in your graph. In our problem, this would be 8 rectangles. So we divide 5 from 8, and that gives us the width of our rectangles, which is 0.625. This width will help us find and graph our left rectangles. We will start first at 1 and then add 0.625 to each value. In order to find your right endpoint rectangles, the process remains the same, except you will always start with x sub 1 subscript, which means your first value will be 1.625, but then you continue on adding 0.625 each time. What we have done so far is find our x values for both our left endpoint rectangle graph and right endpoint rectangle graph. What we are missing is our y values, which help us be able to plant the points on the graph. In order to do this, we can plug in our x values, x sub 0, x sub 1, so on and so forth. In for k, in our sigma notation equation, y equals 1 half times 2 to the 0.625k plus 1 times 0.625. And that's how we get our y values in each of these tables. Now that we have completed these tables, we can plug in these points on our graphs. Once we have plugged in the points for our left endpoint rectangle graph, this is what it should look like. You can see that the curve corresponds with the points that are located on the left side of the rectangles. Now, looking at our right endpoint rectangle graph, you can see that the curve corresponds with the right side of the rectangles. In order to find the total area of your left endpoint rectangle area, you are going to add up all your y values and then multiply that total by your width, which is 0.625. This would be the exact same process for finding your area of right endpoint rectangle area. Add up the y values and multiply by your width. In order to find the average area, you'd add up together your total area for both your right and left endpoint rectangles, and then divide by 2, because in finding the average, you divide by how many there are, and that's how you find your average area. Another way you can find the area under your curve is by using trapezoids. To do this, you would need again to graph your points, the same as you did for your right and left endpoint, but this time you'd include your subscripts that included all 8 rectangles. So you'd start at x sub 0 and finish at x sub 7. This would be because the equation is asking for 8 trapezoids, and from 0 to 7 is a counting of 8. You'd also use all the y values you'd previously found and plant these points on a graph. This time you'd be making a slash mark to make a trapezoid rather than a rectangle. Notice that when you graph this, it will take the shape of a trapezoid rather than a rectangle with a curve that intersects either the left or right side, similar to the left and right endpoint rectangles we just graphed. This trapezoid method is also seen as being even more exact. In order to find the area of the trapezoid, we will use the equation for the area of a trapezoid, which is A equals 1/2 B1 plus B2 times height, or h. This time, the width we used before is now the height, and heights of the trapezoids are now the bases. As you can see, you are plugging in x sub 0 for base 1 in your equation and x sub 1 for base 2, and then 0.625 for your height. You repeat this process for each trapezoid and then add up all of the areas to find your total area under the curve. Now we are going to solve a story problem using speed and time and relate to finding the area under a curve. Here is an example of how speed and time can equal the amount that a distance is traveled. If Frida drives to the Starbucks that is in her friend Lola's hometown and it takes her 3 hours to get there and she drives 60 miles per hour, how far will she have driven to get to Starbucks? We can easily graph this problem in which the x-axis is time and the y-axis is the speed spent driving. The equation to find the distance, which is what this story problem is asking for, is distance equals speed times time. If you multiply 60 by 3 hours, then you will find that Frida drove a total of 180 miles. This relates to the area under the curve, which we found earlier by means of right and left endpoint rectangles and by using trapezoids, because the shaded rectangle represents the area of this curve. It represents the distance that Frida had to drive to get to the Starbucks in her friend Lola's hometown.